Thank you very much. I am glad to be here with two very leading researchers for this Fireside Pat channel. I'm Jitu Padhye, and I work in Azure Networking. And I'm here with Erica and Sylvia Ratnasamy. For past decade or so, both of them have been highly influential technical leaders in the area of networking. And I think we're going to have a great chat with them. Erica has been Microsoft CVP. She's a Microsoft CVP. She has worked in the general software engineering field for over 20 years, and she has recently taken over the leadership of all of Azure physical networking team, one of the largest networks in the world. And most importantly, she has driven our SD and WAN effort. Her expertise is to apply software engineering discipline and principles to a large number of different domains, including engineering systems, security, identity, and most recently, the cloud network. Sylvia Ratnasamy is a professor of computer science at UC Berkeley, and her work focuses on design and implementation of network systems. She has done seminal work going back to her PhD thesis in the areas of distributed hash tables, modular routers, network virtual appliances, and many other areas. She's also the co-founder and CTO of Nefeli Networks. So welcome, both Sylvia and Erica. And let's begin with a sort of retrospective question. You have both been in this area for quite some time. So from the perspective of specifically WAN backbones, and that too of hyperscale cloud providers like AWS, Azure, Google, and so forth, what's the primary lesson you would say from the past decade? So Erica, maybe you can start.
Okay, so I guess I would start that the lesson is really the WAN is I call it's not just a software defined WAN, it's cloud defined WAN. As some of you know that Microsoft had the so-called software driven wide area network effort. It started with MSR, Microsoft Research collaboration, and if you today Google or Bing Swan Microsoft Research, you will find the first one will jump on is 2013. So this is our effort to have a central controller to manage to drive the utilization efficiency of the wide area network. What we learned is like what I just mentioned. It's more than software driven, it's cloud defined. What I meant is cloud actually drives the very different optimization for wide area network. Cloud customers are demanding, and workload are many different types. Right, the assumption of the TCP/IP stack, such as timeout, retry, connection pooling, might vary a lot. And the other thing is that customers have expectation that you are a cloud provider, and you need to, my application need to work regardless who provide the optical connection, and you are the person, right? I'm asking to make my application work. On the other side, we also leverage cloud. The reason we can make this centralized control plane work is because we have cloud. We leverage cloud computing to predict bandwidth need, to do the traffic engineering optimization, solver, and all the work. We work in collaboration with the research and using Azure itself to find the solution to generate optimized routes. Yeah, so that's I would say the lesson is cloud and wide area network, or so-called software driven, when it actually fits each other. Yeah.
Okay. Very nice. Very nice. Sylvia, your perspective?
Yeah, and I have to acknowledge mine is a little bit from an outside view, not
Absolutely.
Being inside a cloud service provider. I think to me, it's really been a lesson in, I would say, both innovation and simplification, in the sense that, we've watched many influential movements and trends in the last 10 years, SDN, NFV, disaggregation, all the way from the radio access networks to how you build router equipment. And to me, what's come out of that is tremendous innovation, that the fact that it's been unlocked and it's not just the vendors anymore that are innovating, it's the cloud providers, it's a much larger variety of players. And that's been great, and the efficiencies and scale that has enabled has been remarkably impressive. If I look at the number of innovations one read in the pre-cloud era versus the post-cloud era in the networking space and the WAN space, that's been remarkable. But it's also, I would say, if I had to put in a note of caution, it's been a lesson in simplification, or rather in the absence of simplification to me a little, in that I feel we've made all this progress. One of the hopes was also simplification of that WAN and network infrastructure, and I'm not sure we're there yet.
That's very nice. So actually carrying on that thread, right, I think what I heard you say is that there have been a number of advances in academic research in terms of simplification, or proposals for new routing protocols or new architecture, or your work on the evolvability of internet backbone. How do you think academic researchers can best work with large cloud providers from your perspective? And then I'll ask Erica the same question about how we can potentially leverage the latest academic research. So what do you want, Sylvia, for example, from providers like Azure?
So let me start by saying that I've had and still have, and I've enjoyed many collaborations with, folks at Azure, like you, Jitu, folks at Google. That's all been great. I think if one had to say, where I would like to see a better collaboration would be in sort of greater transparency and dialogue when you face a problem. So what I mean by that is, if I go and read the latest SIGCOMM paper from Azure or from Google, it describes this really interesting system and has data on a system that's been in production for maybe 1 or 2 years. And I have to imagine, if you take into account design time, development time, testing time, rollout time, that this is actually a 5-year-old idea, which means that you actually were thinking about the problem 5 years before I heard about it. So what I would love to have happen is, dialogue where you, Azure, come to us and you say, we have this problem, we don't know how to solve it. And, these are all the constraints, these are the different ways we're thinking about solving it. Do you have a better idea? What do you think about this? And so that it's a dialogue at that formative stage. The other area, I can pause there. And
No, go ahead.
Put in one more request. I think the other place where I feel like there could be a great change is around sharing of data. I'm sure you've heard this before.
Yes.
But there's so many areas like traffic engineering, optimization, applying ML, where the data really matters. And I think both sides benefit if we can find a way to share that data. It means we do better research because we're grounded in reality. Mm-hmm. It also, I would imagine, is better for you because you have some idea now that this is closer to what you want it to be when you hear a research idea. Otherwise, you hear a research idea, you have to decide, does it work on my network, on my topology, my traffic patterns? Absolutely. If offload that work to the research community, I think we'd be happy to take it.
Awesome. And Erica, from I guess, our perspective, how do you think we can work better with academic researchers? We obviously work closely with MSR, as you already pointed out, but there is a large amount of talent that's outside of MSR, right? And so how do we leverage it effectively?
Yeah, I think that's a very interesting question. I actually see the other angle, from this so-called look ahead thing. I feel that we need to have a lockstep collaboration. So, Microsoft as a cloud provider, I think we are very unique is that we run true DevOps model, right? It's not just the software team run DevOps, the networking team. And so for us, it's super important about the operability and the simplicity. I think Sylvia also mentioned that. And almost when we evaluate every platform, design, research, and everything, that's the top 2 criteria, right? So need to be very easy to operate and then need to be as simple as enough, right? And we also find that even like a Swan, when we first design, I think if you look at paper from MSR in 2013, at that time it's very focused on bandwidth utilization, commodity, router, and those things, right? But for those several years by running it. Yes, those still important, but we find more important because router getting cheaper and cheaper. Okay, so the original idea about memory is not an issue anymore versus the reliability of different. I mean, in the different the world around the world, the reliability, the fiber cards. I can have fiber card like 10 or 20 cards per day, but I still need to keep my network up running. So we actually over the year we continue the SWAN, but we find that we need to add different optimization components or simulation to provide this to deal with the physical world complexity and also the ecosystem of the hardware. I mean, they change the over the year they evolve. So I actually see that I wish this is the kind of lockstep type of a collaboration with academia. Yeah.
So actually, Erica, since you mentioned hardware, maybe we can jump to a question that I had planned to ask maybe a little bit later. So hardware innovation is obviously important in our business. Most of the advances in computing technology, if you look over, have been primarily first driven by hardware, and then later software kind of comes along behind, right? So in WAN, for example, the thing that has always been at premium is bandwidth. And one of the main factors influencing the bandwidth is obviously peering cost, but also the optical technology itself, right? So what are the key advances in this area that you are looking forward to? And then, if you listen to Elon Musk, which obviously everybody must these days, we also see satellite network coming up, and people have proposed all kinds of interesting ideas. And we have a little bit of players. So where do you see these technologies for providing backbone bandwidth going, and what are the advances we are looking towards?
Yeah, actually, I find WAN area is a very fascinating area for me after being software engineer for 20 years because it's really multidisciplinary, like you mentioned, from optical layer, because we run run our own dark fiber. We have a router there, and then software controller layer. And and also like what I described, we need to run a lot of the simulation, need to build a lot of redundancy to keep the network resilience, right? And so the one thing we did innovation, I think in the 400 gig ecosystem, the so-called 400ZR optical module to really bring down the per port price, like a sub 1,000. And so that's kind of one direction to make that kind of the volume, and we work with Google to bring that volume and to reduce the price. The other side, we also have this software component we can develop together in SWAN is bandwidth throttling and brokerage, right? It actually it proven very useful when the COVID hit that suddenly internet traffic increase. I mean, like we actually have 5 times increase of the internet traffic. And SWAN originally designed for the inter-region traffic controller, but the bandwidth brokering and the throttling help us. That component, we leverage that to be able to even out the bandwidth and direct the traffic to other areas. So I think those are still remain the two angle. One is like you say, hardware innovation to bring down the cost, and the simplicity definitely help. The other side is software algorithm respond bandwidth broker, and then we actually want to even respond faster and about those the traffic change. Yeah.
And Sylvia, your perspective, especially on maybe the satellite technology or
it's there. One should find a way to use it. I'm not an expert in either satellite or optical, but I would imagine there are many cases where, particularly in the context of disasters or so on, where you would like to have a fallback. If you can actually engineer your network to fall back to satellite when available, presumably a small fraction of it, certainly.
Okay. So here's another question. In terms of some of the newer workloads that are coming online. So Sylvia, you're from Berkeley, birthplace of Databricks, and the machine learning workloads that they try now, right? And at the same time, their mission here is essentially commoditizing the role of machine learning. So if you look at the AI ML revolution that has swept our field in the last few years, two questions. One is, do you see a role, and how would you leverage AI and ML to improve our operations? What is the role of AI and ML in network management, so as to speak? And the second one is, are these workloads going to drive fundamental shift in WAN traffic, or you don't believe that is the case?
I guess that was for me initially. Let me start with the first one. AI ML has proven useful in many domains. I don't see any fundamental reason why networking would not be the same. So at the same time, I don't think one should use ML or AI for the sake of it. I would view it as a tool. And like all tools, we have to learn what it's good for, and we have to learn how to use it well. I don't think we're there yet in terms of knowing, how useful is ML for fault prediction or for traffic optimization. I think we need to do that work and that research, and we'll get to it. It would seem to me intuitively the reason it would seem useful is because the one thing AI ML is good at is dealing with a large number of messy signals. And when you look at a lot of telemetry performance management systems, we're still talking about probes and pings and trace routes. And there's so many signals out there, from logs at routers to customer complaints to application level performance. And if you really want to take all of those signals and come out with a predictor of failures or predictor of performance problems, it's a hard problem to do manually, whereas AI ML, in theory at least, should be easier to throw all the data at it and it extracts the useful signals for you. That said, I think somebody has to go do the work to see if that's actually true and how useful it actually is.
And so Erica, do you think AI and ML are ripe for use in our operations? How do we use it? And do you think the AI ML workloads that are running in our data centers, are they having any impact on WAN traffic patterns themselves, just by the sheer volume, perhaps?
Yeah, actually, people ask me a lot about that, and also, like I said, that I call cloud-defined WAN, right? It's the cloud drives WAN, but WAN also rely on cloud. It's very similar to that that kind of the fit each other loop that we define that data, like Sylvia said, because no matter you're doing what kind of AI ML, data is a crown jewel, right? And so data need to transfer. I mean, somewhere, and it continue need to be transferred, right? So we start to see that even just very early on that some customer want to use a certain kind of the model, and then the transfer, and then so we usually, when there is a traffic spike, we are the first to know, oh, why this spike a lot. And in terms of the usage, I mean, the other direction, I mean, to help WAN, and I think at this moment I need to admit we use a lot of simulation, we use a lot of optimization, and we haven't yet got to this machine learning things. But one thing I did see the trending is, like I described, I mean, with COVID, we realized that the internet traffic, right, is going to grow, and probably even post-COVID. And if you look at that angle, nobody can simulate internet to some extent, right? Because the definition of the internet is, it's the paradigm of the internet, not to mention what's the current technology. It's really multiple service provider, all kind of different signal and all this. So when you get, I believe when you go beyond that simulation, the sweet spot, the limit of the simulation, you need the machine learning. And I guess the other thing is also the usage, right? Because I think machine learning, if you are kind of more in the usage of not 0 and 1, but also the percentage. And if we get to the point that the customer can accept the percentage of confidence level rather than 0 and 1, that will even make the ML the solution attractive. And I guess I also missed this your previous satellite question. That's interesting in a way. We look at like also from this how to provide the resilience network to the customer, like Sylvia said. Many people, well, the first intuition might say, "Oh, no way! I mean, the satellite bandwidth is still very limited, very expensive, right?" However, we do measure. I mean, at single moment in time, how much the traffic we need to adjust because the physical fiber cut and all this challenge, right? It's actually not that much. However, as a WAN, I mean, people probably can imagine the challenge is that that fiber cut can happen anywhere. Can happen in US, can happen in Latin. And even though the total amount is maybe a relative small percentage of the whole network, but I still need to build redundancies everywhere, right, to prepare. And so that's kind of the bring satellite attractive because at the single moment in time, actually the failure, the loss of the bandwidth is a very small percentage. However, we just don't know where it is, right? So we need to prepare everywhere. So I think satellite, because the nature of the satellite can really help on that. Yeah.
Okay. So talking about redundancies, right? There was recently a very interesting paper about impact of a very large-scale solar storm and how it might knock down global communications and how terrible things would be for all the cloud providers. While the paper was perhaps a bit alarmist, I think it's a question definitely worth pondering, right? How do cloud providers, and perhaps for Sylvia, maybe when you answer the question, how should cloud providers prepare for such a black swan event? And internet, while it was originally conceived by DARPA to be, nuclear disaster resilient and things like that, the argument is that we are not prepared for something like this. So the paper has got quite a few eyeballs. So thoughts? Are we ready for a black swan event of a large solar storm?
I suspect the answer is no, but you folks would know best. It's funny, I actually think, what you just said about that the internet, one of the motivations for the original design was to survive a nuclear attack. Maybe what we need to do is go back to our roots a little bit because, a lot of the design principles when we go back, decentralization, self-bootstrapping, self-discovery, self-organization, all of the old layer 2 protocols and so on, they had that resilience. Whatever partition of the network remained, you would discover the nodes and you would construct routes and you would be able to do addressing. We lose some of that with things like SDN and so on. And so I think it's worth considering whether we should have a bimodal, overlay, underlay design where the underlay is unbeatably resilient. It'll do the best with whatever is available and up. So
that's nice.
Would be fun to do.
Yeah. Erica, your thoughts? We have just 1 minute, so.
Yeah, okay. The quick answer is that we have a white swan, so we can deal with any black swan event. Yeah. I think the very quick answer for that is that it really depends on the failure mode, right? So like I said, we do a lot of simulation based on the historical data, and that probably can also leverage either machine learning or academic field, is that what kind of failure mode that this so-called solar storm can cause. and we can model that and then build accordingly. Like I said, we have many different failure model, even according to geolocation, and then we subscribe subsea cable failure rate data, and to build the network to deal with that. So my ask maybe is for Sylvia, if you guys can provide me the solar stone failure model, I can build accordingly.
All right. So we don't have much time, but I'm gonna deliberately go over 2 minutes, because when we have people like this, we have to ask this final question. Okay. So 2 minutes extra, please. So take out your crystal balls, each of you, and in 1 minute, give me your prediction for next 10 years of internet and WAN. What will happen? What are we looking at? What will be the biggest problems? What will be the biggest opportunities? Erica?
Oh, you want me go first?
Yeah.
Yeah, I like I said, I truly believe the internet paradigm. I think it's not about, I guess I would say, even I'm a technology person, and I think that it's more about the need to overcome the risk. I think when people using internet, and they always have this, okay, there's no guarantee, there's no the failure mode, and all this stuff is unknown, right? So I think for the next 10 years, I mean, the need to come, need to surpass the risk, and whoever can make internet trustable. Okay, when I say internet, not necessarily today's internet, is the internet paradigm, trustable, and no matter it's technology, no matter it's a ecosystem, and no matter it's some kind of collaboration, everything, and that's what we need to move forward.
All right. Okay. Nice. Sylvia, crystal ball.
I think I'm going to go out on a limb here and say I think it's going to be in the last mile and the access, in part because I think cloud providers have been so successful moving workloads to the cloud, building these amazing WANs, moving things to the edge. And so the weak link now is, I think, the last mile. I still have one link out of my home. And there's a tremendous incentive to both the cloud side and the user side that I can just have connectivity anywhere and everywhere I go without worrying about, oh, is there AT&T coverage here? How do I switch to this Wi-Fi hotspot? How do I plug? So connectivity should be like air and water, and with billing and all, of course, in the background, but make that work. I think that's the space where that's the weak link. We should go look at.
So I should have clearly waited to ask the satellite Starlink question until this answer. So that's very nice. Thank you very much. And I think that's the end. Thank you both, Sylvia and Erica. This was a very interesting discussion. Such discussions are, of course, never complete. So let's continue the dialogue. And that's it. Thanks.
Thanks. Yeah.
Thanks, Jitu.
Thank you.
Thanks, Erica.